welcome to this week's edition of Smart Tech. I'm Andrew Barija, your host, and this time around we are going to be discussing the technology in electrical engineering. I'll start by saying quite a number of people embrace the engineering profession, that's globally and locally, and we have a number of universities in Uganda that actually offer this course in engineering and in particular electrical engineering. But the only challenge, the people engaging into this course have been having a challenge of having the machines that are necessary to ensure that they can execute their work efficiently. The innovators have thought through these hardships and they have decided to design a very portable handicraft machine that can replace the big machines which are not even portable and are quite very expensive. This technology is very influential in determining the voltage of electricity and also being able to save your results for future review. Let's get into this. I'll be right back. Electronics engineering is a sub-discipline of electrical engineering which emerged in early 20th century and is distinguished by the additional use of active components such as semiconductor devices to amplify and control electric current flow. Previously, electrical engineering only used passive devices such as mechanical switches, resistors, inductors, and capacitors. Electrical engineering technology applies the principles of electrical engineering. It deals with the design, application, installation, manufacturing, operation, or maintenance of electronic systems, accompanied with a specialized discipline that has more focus on application, theory, and applied design and implementation. It is the largest branch of engineering technology and includes a diverse range of sub-disciplines such as applied design, electronics, embedded systems, control systems, instrumentation, telecommunications, and power systems. A number of universities in Uganda offer engineering-related courses to the applying students due to the great demand of these services within the country. With this initiative, students within universities have taken up a step to make easy the work done by the engineering students, inclusive of actual established engineers, but specifically electrical engineers. The Malmet technology concept, driven by Makerere University innovative students, is one of a kind to quicken and make ease of the work done by the engineers, inclusive of students.
Well, it started from my course itself. As an engineer at college, we actually are expected to do hands-on skills to learn the theory we're getting in class as engineers. But our experience in our labs was quite interesting, whereby you have a lot of students having to share very limited resources in learning the engineering itself. So it expected students who are aggressive are the ones who learned the most, because you have find groups of 20, 15, 5 sharing the limited resources we have in our labs. So from that, I also noticed that everyone in that lab actually had a smartphone. Since we are all campusers, people have smartphones. But we actually don't have tools that enable us to get the hands-on experience for this practical learning. And in the end, you find you have engineers who don't actually fix anything. Engineers who just have papers but cannot fix a percolator at home or a flat iron, and your parents are laughing at you, what did you do? Yeah, it's that dilemma that I thought would come up with something that can help us better learn more hands-on experience. So our idea is called Malmet. Malmet comes from multimeter. So for people who have done engineering or physics, since it's a core at O level and some take it even at A level, would understand that. Malmet is a portable electronic measuring device. A very easy way of understanding it is, doctors have those, I don't know how they call them, they normally put them on. You would identify a doctor from putting on that thing for checking the heart and whatever. For an engineer, especially if he's electrical, you would identify him from the measuring tool, which is a multimeter he would have. So In simple terms, Malmet is that multimeter tool. So we combine a 3 desktop equipment, which is the oscilloscope, which is a big device used to generate functions. This is normally used by telecommunication engineers to measure frequencies and all that stuff. Then we combine it with an oscilloscope, which is another very important tool for both engineering, electrical, medicine. It enables people to measure the signals, to see them very, very well. And finally, we combine the multimeter tool, which is a device you use to measure the voltage in your sockets or in whatever circuit. We combine all those into one small device that uses a mobile phone for students and other practitioners to be able to access those tools cheaply and portably at their comforts of their homes or dorm room or even the class session itself.
We really invested a lot of money, despite the fact that we are students. We really had to put some money, trying to gather the hardware mostly. The hardware part mostly it consumed a lot of money because we were good at the software, but again we had to buy the hardware, the chips and everything. So in total we could have spent an approximation of like 4M for now at the stage where we are. But we try to really try to look for ways of getting money, like grants, and also we try to work for other people because since we are IT guys, we can create websites for people, mobile apps and everything, and the kind of those kind of softwares for people or for companies. And then in the end, we try to get some revenue, and we really use that revenue to invest in our system and also for our welfare. You get? Yeah, so that's it generally when it comes to how much we've invested or when it comes to the financial part of it.
How does the innovation impacted us? So I'll begin with crediting Makerere University, specifically the HEPSA PBL program, where we do problem-based learning. They gave us a small funding for prototyping. So that is the funding we used to actually build our small prototype. And from the response we are getting so far, we carried out questionnaires on whether the device is actually needed with the engineering students we have at the campus itself. And the response was very, very positive. Within our survey, we wanted to find out the key unique features our device has and the use cases. So the use cases will determine how impactful this device will be into the society. And there are several use cases we identified. So Uganda is moving more into the fourth industrial revolution, where we're having more technology coming in. Electricity penetration has greatly increased in the country, and more people are buying electrical equipment, refrigerators, percolators. They're buying smart watches, smart screens, smart fridges, and all that. And we're even having electric cars coming into the play. So there is great room for innovation and growth. So our tool is supposed to come and enable students and enable researchers to innovate more tools that actually work with this electricity. So our tool is fostering research and maintenance of these electric systems we are hoping to come into this country. Solar panels, all those systems. Because if you're installing a solar panel, you would need a tool to actually measure your circuit and know whether it is completely assembled. Our first priority currently is for students so that they basically learn these tools. So with our mobile application, we have short courses or short tutorials of basic embedded systems and electronics tutorials which a student can learn and know how to use this tool to actually build something, an end product. So with our application within the system, you basically get a kit and learn that you can actually repair maybe your percolator at home or anything. The tool is also going to be impactful in the medicine sector. Most times we rely as a country on imported materials. Everything we are getting here is literally mostly imported. And imported materials make maintenance very, very hard and tricky. So you find, for example, at our college itself, we have a lot of dead equipment. The oscilloscopes are dead. A lot of them are dead and can't be maintained easily. So with our tool, we also hope to include simple manuals. So a tool comes with a manual showing you how you can actually maintain a medical equipment, if you're a biomedical engineer, how you can maintain your solar system, if you are an electrical engineer, how you can even maintain your home, if it's a small power issue, or even your car to test if you have battery onto the car itself. So it is going to be very impactful because we are dealing with electricity, which is a serious thing everyone uses.
When it came to software and the hardware and the soldering and everything, the team would do that, but what really lacked was first of all the knowledge and maybe the hardware, the equipment that we needed. The equipment was kind of expensive, and since it was a try and error kind of thing, we had to keep on getting a lot of equipment so that we could try. If this fails, we go to another. For example, at first we had anticipated that the system would be using Bluetooth to connect to connect the hardware to the software. But again, after some time, we realized it wasn't really effective because the Bluetooth signals were coming, but they were slow. We wanted something that could be a little bit fast, so we had to switch to Wi-Fi, and in that process we had a challenge of time. First of all, we had almost everything ready and built on Bluetooth, and then afterwards we had to switch. So it really was kind of challenging because that time most of us have been in final year, so it was really challenging juggling academics and then also trying to come up with the system, or trying to give time to the system to see to it that it's really up and running.
This innovation will largely accommodate students to make work easy when executing different projects due to its uniqueness from the usual electric devices in terms of speed, portability, and cost.
Our first target consumers are academia, like I said. We're going to begin with the technical institutions, higher institutions of learning, and secondary schools, which have this practical learning as a compulsory state. So we're trying to develop smaller equipments which are more portable for students in campus to easily afford. Those doing STEM, science, technology, engineering, and mathematics subjects. Then we also develop some for high schools because physics is compulsory from senior 1 to senior 4, and in the new curriculum we are adopting the more hands-on. So if our tool is fully developed, students will have access to do these practicals at home or even at school for those who would want. So our customers, our consumers, the first ones we have are the academia students. Then later on, we hope to even expand more into practitioners and technicians and engineers who are actually working at industrial level. The current gadgets we are using in our labs are institutions in Uganda, high institutions, secondary. At least those I have been able to interact with since I was a science student, have 4 major gaps within them. One is they are big. So our lab, one of our labs at Makerere, has about 14 working tables. Each working table has those 3 equipment, and that table goes for around 12 million, like one single table, around 12 million or so, if you are to actually buy them. So first of all, they are big, so you would need a bigger space to have them. Then they are expensive. They are expensive, especially the oscilloscope one. It's very, very expensive. And they offer small functionality compared to what I would want as a student. If I'm to buy, I will be able to afford maybe a multimeter and not able to get other devices I want. So they're expensive, they offer fewer functionality, and they are big. Yeah. So with our device, we hope each device to go for about 300,000, so that at least any student in higher institutions of learning can actually afford it. And for those in lower institutions of learning, we hope to have a subscription model on our mobile application of around 1,000 per week of using that device, whereby a student gets access to all those features and he does his projects at only 1,000 subscription with our mobile application. We're aiming at making more sales than making more money from one sale. So with more users, we will definitely make more sales. And it is more affordable for a high school student. If a student in high school, literally, he could not actually afford a bigger budget. But with our pricing, we are looking at a plan so that we know features used by a high schooler are limited, so that's why the fee is small for his case. Then for a person in higher institutions, we can have a different pricing for them as well. But everyone should be able to actually afford our device. What benefits are we offering as Malmet? So there are three core benefits we look at. One is portability, ability of our system to be very portable such that you can carry it anywhere. Our final product will be as small as a key holder, so that if a person has a car, literally can have this device anywhere. And a student with a small dorm room sharing space will also be having enough space to actually learn practically. And the other one is we offer deep functionality. So we are combining literally 3 desktop-based components and putting them into one small one, so that you get all the benefits into one small device with the help of your mobile phone. And the last one is maintenance. So our system is going to be very easy to maintain, since I've said we are doing local manufacturing. So all the spare parts will be locally available, so it will encourage other industries to develop as well. So the maintenance issue will be very, very easy and sorted.
The developers intend to not only promote this innovation locally, but also globally to ensure evolution and sustainability of this initiative.
We developed this solution based on the updated curriculum, both the university curriculum here, the way they do their practical session, and Makerere University being obviously an international university which even adopts people from the East African community, we believe people in the East African region can easily adopt to our system, and our system is very, very customizable. We keep it more open, so as we're demonstrating using the app, you will have to see how easy it is that it can address these local challenges. Then how do we stand out from the global competition, let's say people importing? We are promoting local manufacturing. Most of our hardware was made in-house. We focused on learning how to make everything here and make it customized for the target here. Like the way students actually operate, the way they do their labs, because we are students ourselves. So we put in a lot of design thinking to ensure that we are designing for the real market, the East African market.
How did they start? Though it is still a startup, we discuss the journey of this initiative.
I said earlier on, was appreciating the PBL program at Makerere. It offered us a small grant for prototyping. That was our first grant. Though it wasn't enough, but we were able to roll out. So within the innovation, within the course of the innovation itself, we learned a lot of skills that enabled us to source more funding to invest into the idea itself. Skills like the app development. Our app was developed in-house, so we definitely developed the app from scratch. So we learned that skill, which we also exchanged for money from other people who are interested in app development, and we sourced that kind of funding. That was from my IT department. Me personally, doing embedded and control systems, circuit design, all that also enabled me to get funding, small funding for the project. To actually appreciate my team, we are a very diverse team. It's very important to have a diverse team when you're developing such systems. We have a team from the IT department. Those are responsible for developing the mobile application itself, ground up from everything, UI design up to the app itself. Then we have the circuit department, or the electronics part, where I am part, and I have another teammate doing masters in telecommunication engineering, electrical engineering, and also the mechanical part. We have the mechanical part as well, responsible for developing the casing and fabricating our device. So yeah, I can say we have a diverse team making the whole project come to life. At our stage now, we are at the piloting stage. We have developed our first round of successful prototypes. Low fidelity, of course, you'll see it. So the help we need currently is basically in piloting. If we would have institutions that would allow us to test our device so that we are delivering a standard device to the market, that will be of great help. If we would also have small financing to actually develop these piloting tests, so that we reach at a point of investment, that will be of great help to us.
Welcome back from that, and now we're heading to the second part of the show, where we look at the demonstrations. I remember in SmartTech, we don't just talk about technology, but we also demonstrate technology. How does the technology work? And of course, we bring this to you to the very details. Check this out. I'll be returning to wrap up the show.
Malmet is, like I said, is made up of 3 devices in one. So how is it actually built? So it has normal probes, these ones. These probes are the usual probes you buy with other multimeters and other measuring tools, the positive and the negative one. It has a switch which enables you to switch between different devices. You can switch between the multimeter, then you go to an oscilloscope, then you go to the functional generator, or you go off. Yeah, so you can tune these inputs to any of those devices. It's also made up of a buzzer. The buzzer is to enable you to communicate with it, to give you feedback when it has connected or it has tested. Basically, feedback. Inside it is divided into two sections. The analog front end, which is this section. So this section is basically supposed to get a signal, let's say, from your voltage lines, let's say your socket, which is a very high signal. And this signal is supposed to be put into levels that are easily read by this small one. So it basically converts a big signal, whatever signal it is you're using, to a suitable signal for our device. Then it also has a digital front end. So this digital front end has 2 purposes. It is the one responsible for creating Wi-Fi, since we use Wi-Fi. So this is the digital front end. So it is, in this case, we're using an MCU, which is an ESP32. So this one creates Wi-Fi, the Wi-Fi we need for connecting to a mobile application or your PC. So once the signal has been converted to a level that is required, this device creates Wi-Fi, and that Wi-Fi serves that signal to our mobile application. So in this case, we are using the mobile application, but any device that is connected to that hotspot can be able to read that data. Yeah. So currently, we connect up to 2 devices, but they can go to a maximum of 8. So you can have one device serving 8 other devices. Let's say if students are in a group and there are many, so each device can easily be served by one.
This app you're seeing here, this one here, is the Malmate app. It's the one which acts as your screen to take the readings or show you the readings that you've gotten. So it connects to the Malmate hardware or the Malmate device via Wi-Fi. And so let me try to open it and then take you through. So when I open it, for the new users, it brings up that screen. So if you're a new user, you will have to first sign up. So let me just go through a simple sign up process with you guys, and then we continue. So let me just put any name. Let me just put my name. It's Alan. Like that. Maybe let me just put any email. I'm just going to put an email. Let's say alan@gmail.com. @gmail.com. This. Then I'll put a password. Let me just put 1 2 3 4 5 6. Is it 5 6? So that's what I've put. Let me just copy it, paste it here, and also paste it here to confirm my password. Signing you in. So yeah, when I sign up, I'll get an interface like that, and it will be customized according to the credentials you gave us at first. For example, when it comes to the name and your email. So you'll have options. For example, we have options up there. Let's talk about the multimeter, the oscilloscope, and then the functional generator. And then we have more buttons down, or more options. We have, let's talk about measuring voltage, measuring the capacitance, resistance, currents, and everything. So let me just tap on measure voltage. So that's how the screen looks like. So when you put your probes to the circuit that you're trying to measure, or the circuit whose voltage you're trying to measure, then it will give you, it will bring here the digits, or it will bring here the measurings. So for example, if you had like maybe let's say 10 volts, it will bring here the 10 volts. And within here, you can hold or save your results. So I'll show you another feature whereby you can create a project or come up with a project. So for example, for the students, they are given a number of measurements to make, and then afterwards they have to tabulate it and make some calculations. So this system will be helping you when you create a project. It will be helping you to automatically save those readings, such that you don't need to first write them down and then do this and this. So after that, you can now measure. You can switch between direct current and alternate current. So when I go to alternate current, it will look like this, and this will be highlighted, or this will look active, the alternate current side. For the multimeter, I can switch between measuring voltage to measuring current to measuring resistance. So when I go to current, that's how it will look like. And for this, the maximum voltage is the maximum voltage for direct current should be 100 volts. So I can still switch to maybe another, I can move out of the multimeter and then maybe go to another instrument. For example, this time around, I'm going to show you, let's go to the now the oscilloscope. Let's look at the oscilloscope and how it will look like. So when I choose the oscilloscope, it will automatically change your screen to enable you have a bigger view. And the reason as to why you're not seeing the graphs plot themselves is that we haven't yet connected the hardware to the software, and we shall look at that in the near future. So let me try to show you more features of the system. So we have more features. For example, we have the team part, whereby students working on the same project can communicate between themselves and try to discuss maybe what they are trying to do and the likes. So this will be the team part. This will be the team part. And when you create a project, you can add more of your friends or more people working on or using Malmet as your team members, and then you'll be able to discuss and talk about what your progress. Yeah, so we have another part here. It's called the market. So this part here will have it's blank for now, but it will have things that are being sold, because we anticipate to start selling circuits and chips, locally made circuits and chips. So you'll be able to see this, you'll be able to see that here. So we had the challenge, most of the chips that come from abroad take a lot of time to reach within the country, and we are trying to mitigate that. We are trying to make sure that students or people who use chips get what they want in the least time possible, so as to enable the smooth running of the activities. And another part that I would show you is maybe this part here. Now when you tap this part is now when you're trying to connect your Malmet or your hardware to the software. And when I turn on my device, I'll be able to show you that. I'll be able to take you through the process of connecting the devices so as to enable communication or intercommunication between the two devices, the hardware and the software. And what I want to tell you is that everything you see here was in-house, made by us. Of course, with the help of a few people like the doctors, most of for the hardware part, but the software is specifically made by us and the team. Another part of the system is now this projects part. So this part here will have the projects that people are currently working on, and it will be able to measure or to show you your progress, how far you've gone. Maybe, for example, you're supposed to take like 10 measurements, and then you have to get those results. It will tell you how far you've gone and how far you need to go. So this will be the part for projects. If you want to create a new project, just press on create new. We shall enable that button later. We are still focusing on the hardware part, intercommunication, but that's how the projects page will look like. So this projects part will have sample projects and student projects. Sample projects, I mean projects that you can open and learn from. Model projects that you can use to as your basis of learning. So that part there has most of our settings and menu. It has a profile. You can change the name of your the name on your profile and everything. So for example, this time around I put Alan as my name. I registered as Alan. But if you want to change that, you can go to your settings and do that. You can upgrade to premium features. We shall have premium features. For example, those people who work with high voltages and everything, they will be under premium features, and we shall look at that later. You'll be able to see what devices are connected to the Malmet, and you also be able to look at to get support. We hope to put a a 24/7 support to help our users. For example, in any case, or maybe let's say, for example, they fail to connect the hardware to the software and the likes, we shall have a 24/7 support to help them with that. We have also that part where you can share the APK with the app with your friends or recommend to them. And also we have the AI clinic. So that one will be an artificial intelligence based kind of diagnosis, whereby you put the behavior. You can be able to input the behavior of your machine or of your device, and then it will tell you probable causes, or what could be the cause, or what could be the let me say the cause of the problem of your device. Now when we are now we have powered our Malmate. It's on. That's why you can see this indicator light. It shows that it's on. So now we are going to connect it to the software, and then now this is how we do it. We are going to go to the add device part here, and then we shall try to locate it. We shall try to locate the Malmate among these, or let's try to scan and see. So when we scan, we have Malmate already there. So we are going to switch and connect to it. So we are now going to connect to Malmate instead. So it has connected, and now we can go back to our. We can now go back, and it will show us that it's connected to Malmate. See, so this tick here, when you look at this check, it shows that it's now connected to Malmate and ready to communicate. Yes, please. So after that, we can now go back to our home screen, or we can now go back to the voltages part and then try to take measurements. So my friend here will try to get the probes and try to do some measurements.
So you can measure like resistance if you have a resistor. It's a common parameter students also measure. If the values are changing, you can hold values so that they remain constant. You can resume, you can save values, like he said, those values appear in a table. So you have the timestamp when the value was recorded and the value itself, which is important for students making reports as well. You can go to another screen, the voltage screen. You can go to a current screen and typically do the same thing, save, hold, all that. Then you can come back to the home page, and with the scope bit, once you click, the screen goes horizontally. It should appear. Let me get the graph 1 second. Let me connect it. So once you connect it for the scope, this is the way it would appear. Currently, we're sending a signal, since we don't have a functional generator on here. This is a signal coming from the device of around 800 Hz frequency. It has some distortions, but those are part of the future work we're going to actually eliminate to make sure that the graph is very smooth. So that is the way your graph would appear if you're a student and you're trying to measure. Yes, which is exactly the same with the state-of-the-art desktop device you would have.
We have switched to measuring voltage, and now let's try to see. So I can now hold, and I can now pick that value that I've held, or I can resume measuring, or I can save that value that I've got if I think it's perfect. So after saving, I can resume measuring, and now you'll see the digits trying to change. So that will be the voltage, the current voltage. So I can again hold, and then when I go here, I'll be able to see to see the measurements I've saved. I've only saved once, so when I save again, I'll be able to find my measurement there. And with this, I will be able to send it to a given table for that particular project that I've created.
Did you like that? I personally did. You can see the brilliancy among us, the students in Uganda. And these are local innovators, something very interesting, that are coming up with solutions to the society, and in particular this time around to the electrical engineering students. Remember, on Smart Tech, we explore technology and its impact to the business world. And in most cases, it's giving a solution to the hardships that the community is facing in regarding to executing the required economic activities. I've been Andrew Barije. Thank you for being on Smart Tech this week's edition. Till next week, goodbye.